then exercises. Chapter 12 is short. Okay, chapter 12 is short. First of all, I want to remind you that we have a lecture this Sunday morning at 9 Sunday morning. Okay, I will review I will give you some examples to do for the midterm exam. Okay, in Vietnamese, I will explain everything in Vietnamese to make things easier for you. Okay, if you are busy on Sunday morning, then you can join the lecture on Sunday afternoon at 2 p.m. Okay, the same question, the same examples. Okay. All right. Chapter 12, carboxylic acid. Okay. So in carboxylic acid, we have COOH. Okay, COOH. Also, we have C double bond O in carboxylic acid, but carboxylic acid is completely different from aldehyde and ketone. Okay, different. Okay. Sorry. For the nomenclature of carboxylic acid, we have systematic name and common name. I mean, IUPAC names and common name. For common name, you need to remember some popular carboxylic acids, such as formic acid or acetic acid. Okay. COOH, formic acid or acetic acid. Okay. For IUPAC names, we put oic acid at the end of the corresponding hydrocarbon. Okay, so we have, for example, acetic acid is a common name, and its IUPAC name is ethanoic acid. Okay, remember acid at the end. Okay. We have some famous natural occurring acids and its derivatives, such as lactic acid, okay, succinic acid, oxalic acid, citric acid, or we can have ester, benzyl acetate in jasmine flower, or isopentyl acetate in banana. Okay. So how to make carboxylic acid? Oh, I need to ask some of you, because actually we don't have any. Mai Viết Cường, are you there, Cường? Mai Viết
Yes,
Cường, are you
yes,
there?
teacher.
Mai
Yes.
Viết Cường.
Yes.
Okay, can you tell your friends how can we make carboxylic acid? How to repair carboxylic acid?
I think we can make carboxylic acid by oxidizing alkaline benzenes.
Okay, alkyl benzene at high temperature. Okay, that is the first method. The second method is
we can do I think hydrolysis of nitriles.
Nitrile. Okay, C triple bond and hydrolysis of nitrile. Good. Number 3. Method number 3. The third method is we can
Mm, uh,
So number 2 is oxidized alkyl benzene at high temperature. Number 2 is to hydrolyze nitrile. And number 3, you studied a few weeks ago.
what is it? I forgot. What is
The Grignard reagent. How to make carboxylic acid from Grignard reagent?
reagent?
Magnesium.
We can use reagent with carbon dioxide.
Okay, CO2, good. Okay, and then hydrolysis. That is method number 3. What about number 4? Number 4 is very popular. Can we make carboxylic acid from alcohol?
Yes, you can. I think. Yes,
okay, we can buy.
Oxidizing ethanol.
Okay, oxidizing alcohol. Okay, oxidizing alcohol. All right. Okay, thank you. Good. Okay. We don't have new reactions. So we can make carboxylic acids from Grignard reagents. Okay, by carrying out the reaction between Grignard reagent and carbon dioxide. Okay, we studied this reaction a few weeks ago. Okay. You know that in CO2, this carbon is partially positive, and the carbon connected with magnesium is negative, so negative attack to positive. So we have nucleophilic addition. Okay, and after hydrolysis, we have carboxylic acid. Okay, remember that this is in this method we add one more carbon to the to the high carbon skeleton. For example, here we have rubyl magnesium bromide 3 carbons, and in butanoic acid we have 4 carbon. 1, 2, 3, 4. Okay, we add carbon. Okay. Method number 2, we can hydrolyze nitrile. Okay, hydrolyze nitrile. And how do we have nitrile? We have nitrile from alkyl halide by carrying out an SN2 reaction with CN, for example, KCN, potassium cyanide. Remember, this is cyanide, anion, but this is nitrile, the name. KCN is potassium cyanide. Okay, but here we have ethyl nitrile. Okay, and we have we hydrolyze a nitrile, and then we have carboxylic acid. Okay, this is also in this method. We also add one more carbon atom to the carbon skeleton. For example, here ethyl bromide, we have 2 carbons, but in this carboxylic acid we have 3 carbons. Okay, so we add one more carbon compared to the starting alkyl halide. Okay, and of course we can have carboxylic acid from primary alcohols. Okay, not secondary, not tertiary, because you know the secondary alcohols will be oxidized to ketones. Okay, so primary alcohols can be oxidized to carboxylic acid. Actually, first it is oxidized to aldehyde, but it is very easy to oxidize aldehyde to carboxylic acid. Okay, so eventually we have carboxylic acid. Okay, if you want to get the aldehyde, you need to use a soft oxidizing agent, that is PCC in dichloromethane. Okay, and then we can get the aldehyde. If we use other oxidizing agents, For example, H2CrO4 or KMNO4, you will get the carboxylic acid. Okay. And of course, we can get carboxylic acid from aldehyde. You know, it's very easy to oxidize aldehyde to carboxylic acid. Okay, easy. It's easy. To make aromatic carboxylic acid, I mean benzoic acid and its derivatives. Okay, we can oxidize alkyl benzenes. Okay. Remember, we need to use strong oxidizing agent at high temperature. For example, we can use KMNO4 at high temperature. Okay. And remember that it doesn't matter one carbon, CH3. It doesn't matter longer. For example, here we have C4 carbons. It doesn't matter primary alkyl groups or secondary alkyl groups. Eventually, we have the same COOH. There is only one carbon left in the form of COOH, connected directly to the benzene ring. Okay. This reaction occurs through a radical pathway. Okay. Radical mechanism. Okay. So we need to produce a radical. So if you want this reaction to occur, you need to have one hydrogen, at least one hydrogen on the carbon right next to the ring. So if we have something like, you know, T-butylbenzene, look at this alpha carbon. Okay, the carbon next to the ring. There is no hydrogen. Okay, so we cannot produce a radical from here. So no reaction. Okay, so you will see this reaction in exams. Okay, remember there must be at least one hydrogen atom on the carbon right next to the ring. Okay, if we don't have that hydrogen, no reaction. Okay. Okay, that is how we make carboxylic acid. Okay. And so what can we do with carboxylic acid? What can we do with carboxylic acid? We can, from carboxylic acid, we can make ester. We can make ester. Okay, we can make ester. Esterification reaction is a very famous reaction between alcohol and carboxylic acid. Okay, that is a reversible reaction with an acid and a Protest acid catalyst or Lewis acid catalyst. Okay, next semester you will go to the organic chemistry lab and you will make ester. You will make ethyl acetate from ethyl alcohol, ethanol, and acetic acid. Okay, this is the reversible reaction, two-way reactions. Okay, remember the oxygen here, the oxygen with single bond in the ester is the oxygen from alcohol, not from carboxylic acid. Okay, because the mechanism is this negative oxygen will attack to the positive carbon here. Okay, so eventually this oxygen is from the alcohol, not from carboxylic acid. Okay. And as I told you in alcohol chapter, we can make ester from alcohol and carboxylic anhydride. Remember, anhydride, not anhydric. Okay, anhydric is not English, it's French. Okay, or we can make ester from alcohol and acyl chloride. Okay, you know, in acyl chloride and anhydride, this carbon, I mean the carbon in the C double O is very positive. Okay, so these two reactions occur easier than the reaction between alcohol and carboxylic acid. Okay. This is one-way reaction. We don't need to use catalyst here. However, anhydride and acyl chloride are expensive. So normally people still use carboxylic acid. Okay. how to make, let me ask you one question, okay. Nguyễn Ngọc Huy, are you there, Huy? Nguyễn Ngọc Huy, are you there? Nguyễn Ngọc Huy, absent. Phạm Tấn Khang.
Yes.
Phạm Tấn Khang. Okay, can you tell your friend how to increase the yield of the ester in the esterification reaction? How to improve the yield? How increase the yield of ester? This is a reversible reaction. So how to improve the yield of this reaction?
You increase the temperature or the acidity.
Increase temperature or?
The acidity.
Sorry, the
acidity.
Acidity. What do you mean by acidity?
Like you add an acid.
You mean the catalyst? Is that right? Okay.
Yes.
What else? Okay, but with the same temperature, with the same amount of acid catalyst. What else can we do to increase the yield of the ester? This is a reversible reaction.
You remove the water?
Yeah, we can remove. It's so noisy. What's wrong with
it? There's a fan behind me.
Okay, we can remove water. Okay, or
distill the ester.
Yeah, distill the ester, or so you can remove one ester or water, or so we can take out the product, the ester or water, or we can
add more reactants.
Okay, add more reactants. So we can add more alcohol or carboxylic acid, one of them. Okay, thank you. Okay, so we need to use one excess amount, one reagent, one starting materials, and normally people use excess alcohol. Okay. Yeah. Remember the name of the ester. That is the name. For example, ethyl acetate. Okay, just name of alkyl and then carboxylate. Okay. Remember, we can have the intramolecular ester formation. Okay. For example, we have 4-hydroxybutanoic acid. Okay, we have OH and COOH on the same molecule. Okay, and then this OH can react with this COH to make a ring. And remember, we can only produce 6-membered or 5-membered rings. Okay, not 4, not 7. Okay, do not produce 4 7-member rings. Do not produce 4, do not produce 7-member rings in your exam. Okay, only 6 and 5-membered. Okay, so we have intramolecular ester formation, and then we have lactones. Just the name. Okay, we have lactones. Okay, and because esterification reaction is a reversible reaction. It is a reversible reaction. So if we add water, if we add more water to the ester will be hydrolyzed back to carboxylic acid and alcohol. Okay, we can hydrolyze by using acid catalyst or basic catalyst. Okay, and if we use something like sodium hydroxide, we have carboxylate sodium. Okay, and this is the main component of soap. You know, we can make people make soap from cooking from coconut oil. Okay, as that is triglyceride. Triglyceride is okay. Let me ask if you remember what is triglyceride. Đinh Tấn Quang, are you there, Quang? Đinh Tấn Quang. Đinh Tấn Quang. Okay, turn on your microphone. Turn on your microphone, Quang. You don't want to talk to me, Quang? You hate me? Turn on your microphone. You don't have microphone, okay. Châu Hồng Nhung, are you there? Châu Hồng Nhung, are you there? No microphone. Okay. Văn Xuân Thịnh.
Yes.
Okay, can you tell your friend what is the main component of cooking oil?
What can you say again? Yes and no.
Tell your friend the main. Okay, the main component of cooking oil.
This is the lipid.
You know the. Okay, more specifically.
Glycerol and
okay, the ester between glycerol and
chất béo
and sorry,
acid béo.
Okay. Adipic acid, aliphatic fatty acid. Okay. Okay. So that is the ester between glycerol and fatty acid. And but what is name? I should tell you. Triglyceride.
Triglyceride.
Okay, it's not triglyceride. Okay, triglyceride, not triglyceride. Okay, so can you tell your friend if you mix cooking oil with sodium hydroxide, what would you have? Cooking oil with sodium hydroxide. What is the product?
This will the acid and natri acid. The
sodium, not natri.
Sodium mass.
Okay, but do we have carboxylic acid here? It is a base, so the product is not carboxylic acid. It is
salt.
Salt. Okay,
Salt.
sodium. Carboxylate. Sodium. Okay. Thank you. Thank you, Then. Okay, and that is the main component of soap. You know soap. Okay. Detergent, soap. I remember that detergent is not soap. Okay, the main component of detergent is sulfonate. Okay, and the main component of soap is salt of is carboxylate. Okay, salt. Okay. All right. Okay. And this reaction. Okay. If we use triglyceride and sodium hydroxide, and then we have soap. Okay. Ester also have another interesting reaction, that is a transesterification reaction. Trans means it change. Trans esterification reactions means it change. Okay, that is the reaction between ester and a new alcohol. Okay, so look at the structure of ester. You know, ester is formed by the reaction between carboxylic acid and an alcohol. Okay, if you mix ester with a new alcohol, for example, if you mix with the blue alcohol, okay, and then the blue alcohol will replace the yellow alcohol part here. Okay, so we have a new ester, and then produce new alcohol. Okay, so this alcohol will change this alcohol, and then we have new ester and new alcohol. Okay, this is trans-esterification reaction. Okay, and this reaction is very important in making biodiesel. You know, biodiesel, bioethanol is if you go to gas station, you will see bioethanol. Okay, but for the truck, okay, for the truck, the heavy car, okay, the heavy side lorry or truck, we have to use diesel, okay. So people mix triglycerides, I mean oil, coconut oil, for example, with methanol, okay. So we have methyl ester, okay. That is the main component of biodiesel, okay. And similar to alcohol, we can replace the OH. We can replace the OH in acid, in carboxylic acid with halogen. Okay, chlorine atom or bromine atom by using SOCl2 or PCl3, PBr3, PCl5, something like that. Okay, and then we have isochloride. Okay, isochloride. Okay. Let me ask you something. Lý Quang Vinh.
Yes, teacher.
Okay, can you tell your friend, what can we do with COCl? For example, acetyl chloride. What can you do with this one? This isochloride can react with what? For example, CH3COCl. Okay, what can we do with that CH3COCl? Okay, what can you do with that CH3COCl? We just studied that reaction a few minutes ago. Quang Vinh, a few minutes ago. Can we make ester from CH3COCl, Vinh?
Yes.
Okay, so answer my question. The first is the reaction between CH3COCl and
ester.
No, not ester. Ester is the product. CH3COCl and what to form the ester?
Acid carboxylic.
No. That is CH3COCl is the derivative of carboxylic acid. With what? What can react with CH3COCl to form an ester, not acid? Oh my God! I just told you a few minutes ago.
Alcohol.
Okay, good. So the first is the reaction between CH3COCl with alcohol, and then you have ester. That is the esterification reaction. Second, Vinh. For example, just give me anything you can remember. You can carry out the reaction between CH3COCl and a very famous reaction, and you will see it.
Benzene.
Good, with benzene. That is, what is the name? What, you don't remember the name of the reaction? Do you remember the name of the reaction?
I don't remember the name.
Okay, that is Friedel-Crafts acylation reaction. Okay, So CH3COCl react with benzene to form what? What is the product of that reaction? What is the product of that reaction, Vinh? What is the product, Vinh?
Benzoyl chloride.
No, not benzene chloride, but it has C double O. Okay, the ketone. Oh, ketone. Okay, it has the ketone. You will see that reaction in your exam, Vinh, midterm and final, Vinh. That is a very important reaction. Okay, thank you, Vinh. Okay, so when we have CH3COCl, I mean acyl chloride, we can carry out the esterification reaction with alcohol, and we can carry out the phenol graph acylation reaction with benzene, okay, with fluid acid, and we have aromatic ketone. Okay, you will see this reaction in your exam. Okay, reaction of acyl chloride. Okay, so we can carry out the reaction between COCl, I mean acyl chloride with alcohol, and then we have ester. Okay, for example, from benzene chloride and methanol, then we have methyl benzoate. Okay, or we can carry out the reaction with of acyl chloride with phenol. The same, we have ester of phenol. Okay, and of course with water, then we get back to carboxylic acid. Okay, and now this is the new reaction. Actually, it's not very new. Okay, we can carry out the reaction of C double O Cl with amines, and then we have amide. You can say amide or amide. I don't know why some people say amide, some people say amide. Okay, it's very easy to remember this reaction. You know, look at the reaction, the esterification reaction. CH3O. So this is oxygen, I mean methanol, and then we have ester. Okay, then if you replace the oxygen by the nitrogen, I mean replace CH3OH by CH3NH2. Okay, we have the same mechanism. So if you replace oxygen here, then you replace oxygen in the ester by the NH, by the nitrogen. So we have amide. It's very easy to remember. Just remember the esterification reaction and replace the oxygen in alcohol by the nitrogen, I mean the amine. And then here with the alcohol, we have ester O CH3. And if amine, then we have NHCH3. Okay, so this is amide. Okay. Okay. And of course, we can have the anhydride. We can carry out the reaction with a salt CH3CO C anion, COO anion. Okay, so we have you study this reaction at school. I mean, at high school, molecule of carboxylic acid, and then we have anhydride. We can use chloride to make anhydride. Okay. Okay. Not only primary amine, but secondary amine, tertiary amine can join the amide formation. Okay. I say again, it's very easy to remember this reaction. You know, I say again. Okay. If it's easy to remember the esterification reaction, okay? If this is oxygen, then we have ester. Then if you replace oxygen by nitrogen, so replace this oxygen by nitrogen. And of course, NH, because nitrogen has 3 valent bonds. Okay, so if you replace, if here we have oxygen, then we have ester. Then if you replace oxygen by nitrogen, then we have amide. Okay, okay. So if here CH3OH, then we have OCH3, okay? And we have similar reaction. You remember the trans-esterification reaction? This one. Esterification reaction. Okay. If so, you use the new alcohol to replace the alcohol part in the ester. Then replace it oxygen by nitrogen. I mean this one. Okay. Third, replace the oxygen by the nitrogen. If we have CH3 OH, then here we have OCH3. But if you replace the oxygen by nitrogen, I mean if you use CH3 NH2, then here we have NHCH3. Okay, same mechanism. Okay, and after you have amide, after you have amide, you have similar reactions of ester. You know, we can carry out the hydrolysis. Okay, but at very high temperature, not low temperature. Okay, for the ester, we can hydrolyze ester at low temperature, but for ester, we need to heat it up to at high temperature. Okay, okay. So for the ester, I mean the CH3COO here, just add water at room temperature, you still have the hydrolysis. Okay, but for amide is more stable, so you need to heat it up at too high temperature. Okay, and so get back to carboxylic acid and amine. If this is ester, then we have carboxylic acid and alcohol. Okay, if this is amide, then you have amine here. The only difference is for ester, you can carry out the hydrolysis at low temperature, room temperature. But for the amide, you have to heat it up to high temperature. Okay, heat it up to high temperature. Okay, you can have something like the trans-esterification reaction. You know, for the trans-esterification reaction here. Sorry. Okay. This ester with a new alcohol, this alcohol will replace this alcohol. The blue will replace the yellow. Okay, here we have the same thing. Just replace the oxygen by the nitrogen. Okay, so if amide with alcohol, so this one will replace this one. Then we have ester. Okay, but you need to heat it up to high temperature, very high temperature. Okay. Next reaction is the Helmholtz-Zielinski reaction. That is the reaction of the alpha hydrogen. I mean the hydrogen on the carbon next to the C double bond O. Okay. If you just use bromine with temperature or UV light or peroxide, then we have no more bromination reaction. The reaction will occur at tertiary carbon, and if you don't have tertiary carbon, then the reaction will occur at secondary carbon. Okay, but if you have phosphorus, okay, for example, PBr3 or even phosphorus, okay, then the reaction occur on the carbon next to the COOH, right next to the COOH. I say again, without phosphorus, it's just a normal bromination reaction. The bromine will occur at the tertiary carbon. If you don't have tertiary carbon, then go with secondary carbon. Okay, but if we have phosphorus, the bromination reaction occur at the alpha carbon. I mean the carbon next to the C double bond O. Okay. Okay. Because look at the mechanism, you know, the OH will be replaced by the Br. Okay, we have replaced the Br. Okay, and then you have tautomerization, and then we generate the double bond here, like the enone. Okay, and add the bromine atom here. So the reaction occur at the carbon right next to the C double bond O. Okay. Okay, so we have phosphorus here, so the reaction occurs, and of course, this is the alkyl halide. It has substitution reaction or elimination reaction. Okay. And next reaction is the reduction reaction. I told you already, it's very difficult to reduce carboxylic acid. Okay, we cannot use hydrogen, we cannot use sodium borohydride. Okay, we cannot. So do not use hydrogen, do not use NaBH4 to reduce carboxylic acid, ester, or amide in your exam. And the only reducing agent is lithium aluminum hydride. Lithium aluminum hydride. Okay. Okay. So now look. Carboxylic acid, and we have CH2OH, easy. For ester, we have 2 alcohol, easy. For amide, this is the only difference between amide and ester. You know, when you reduce ester, we have 2 alcohol. But when you reduce amide, you have amine. Okay, and no more oxygen. Remember, the oxygen say goodbye to the molecule and disappear. I mean, we remove it in the water form. Okay, no more oxygen here. Normally, C-double-bond-O is reduced to COH. But in amide, the oxygen disappear. Last year, not just last year, actually, every year, lots of students make a mistake here. Normally, you have CH and then OH here, because normally C-double-bond-O is become COH. But for amide, the oxygen disappears, so no more oxygen here. Okay, so take a note here. Everyone, take a note here. Take a note here. Take a note here. No more oxygen. No oxygen in the amine product. Okay. Lost student make a mistake here. We put the OH. So we have put CHOH here because C-double-bond-O becomes COH. Okay. I say again, no more oxygen here. Okay. All right. And now I want you to take a note again because you will see this in your exam. Okay. Let me open the file. Take the note carefully. Take the note carefully. Okay, let me open the file in your exam. Okay, but I need to ask some of you. Hồng Sơn, Trần Ngô Hồng Sơn, are you there, Sơn? Trần Ngô Hồng Sơn.
Yes.
Thank you. Okay, can you tell me what is the product CHO? So what is the product here? The first reaction is R, C,
Or C.
H,
D.
D, and O.
O.
What?
No NA.
No, not NA. Okay, NA is the first, but how about the second? The second. After the second step, we have hydrolysis. So O. We have O and A, and then T3O plus. So O.
OT.
OT. Very good. What about the second one? For carboxylic acid, we carry out the reduction reaction with lithium aluminum hydride, but with D4, not H4. So what is the product? R,
C. O.
How come O? Reduced.
R.
Yes, C-double-bond-O will become C.
C. D.
D. What else?
CD.
CD what?
T.
No, not T. How come it's T? In the first step, we don't have any T here.
Yeah, sorry.
So we have OT, okay? OT after hydrolysis, but CD what?
CD3.
CD3. So carbon 5. carbon is 5 or 4? Around carbon, there should be 5 valent bonds or 4 valent bonds.
4.
4. So CD? CD
CD2.
what? 2. Okay, good. So CD2. Okay. CD2. Okay, what about ester? We have R,
RC.
C, D,
D. D2.
D2, O,
O.
T.
2T.
And the second, in ester, we have 2 products. CH3, O,
3.
ODO,
OD.
How come it OD?
OT.
Oxygen is negative, D is negative. Okay, remember in organic chemistry, negative like positive, okay? Oxygen is negative. So how come it combined with, you know the D here is negative, positive, sir?
Negative.
Negative, okay. So negative add to positive, negative never add to react with negative. So we have OT, okay, OT. Okay, let me try OT. Okay, so we have CH3OT here and CD2OT here. Okay. Okay, what about amide? Okay, so we have R, C, B, 2, CD2, and CH3. Okay. And let me try. Sorry, let me try. Okay, everyone, take this note carefully. You will see all of these 3 or 4 reactions in your exam. Take note carefully. Okay, of course, in your exam, if you have NaBd4, so it should be CH3. Okay, remember in NaBd4 or lithium aluminum hydride, I mean LiAlD4, the hydrogen is negative, that is a hydride. Okay, and in H3O plus, T3O plus or DO3O plus, the hydrogen is positive. And remember, negative combined with positive and positive combined with negative. Okay. Okay, thank you, sir. Everyone, take note carefully. Take note carefully. Take note very carefully. Very carefully. Okay. Take note carefully. Okay. I say again, these 4 reactions are very important. Okay, in your exam, you will see this reaction again. Okay, so remember, and you know that in your exam, it's easy to get 2 marks from these questions. Okay, so just remember these 4 reactions. Okay, all right. So this is the end of chapter 12. Okay, now I give you the first test to do. Okay, the first test to remember, this is to review for both the midterm and the final. Okay, can you see it? Can you see the screen? Can you see it, everyone? But then this is either top C13. Okay, and oxygen 18. Normally oxygen is 16, but here we have oxygen 18. Okay. So what is ABC? But give me everything. Okay, and try to do this this one. You will see something like this in your final exams. Okay, of course not this one, but wow, the structure of the carbon skeleton is different, but the reaction remains the same. Okay, so do it. I give you half an hour. Try to get correct A, correct B, and correct C, and then submit your answer onto BK e-learning before 10:35. Okay.